My name is Donovan Brady. I am the Director of Solutions Architecture here at Logicworks, and I'm going to be talking to you about automation and security in a cloud DevOps world. Just a little bit of background on Logicworks. We are a cloud solutions provider specializing in managed services and professional services in both AWS and Azure public clouds. This presentation is going to be focused on AWS architectures. However, it should be noted that all of these principles are basic general principles for building a DevOps, DevSecOps automation pipeline in your cloud environment, whether it's AWS, Google, Microsoft, Oracle, Alibaba, you name it. These are best practices with just a few AWS examples. So, what are we going to talk about today? We're going to talk about the principles of DevOps in the cloud, and then I'm going to take you through some suggestions on how you can actually design an automated environment following these principles. Then I'm going to give you a quick customer case study, and to then finally talk about the DevSecOps automation. I welcome any questions in the chat. Happy to stop at any point. If we were in person, this would be very interactive, but maybe soon, right, Ron? Maybe in a couple months.
Your mouth to God's ear.
Yeah. The days when IT managed monolithic, infrequently modified systems are way beyond us, right? They pretty much are a thing of the past. Right now, we're pretty much managing all microservice-based architectures. Ron, you just mentioned it with Kubernetes and containers and serverless. So how do we actually keep up with that demand? How do we keep up with the growing potential for automation and DevOps and security? Well, automation is the real answer. The only way to efficiently manage your infrastructure changes in an automated world is to automate your changes. Most customers come to Logicworks with four main questions. One, how do I modernize my platform and tools while maintaining security, while maintaining operational excellence, but also do it cheaply? Kind of sounds like it's not possible, but use the tools that we're going to talk about today, and it is very possible. People tend to think that the only way to solve problems is to throw a bunch of money at it. Oh, well, we're going to buy the most expensive tools, and we're going to be able to automate everything and blah, blah, blah. Right? It doesn't necessarily correlate that way. You need to make sure that the tools that you're buying are actually going to support your ultimate goal, right? In the old world, you buy better hardware, you buy the most CPUs and cores that you could possibly find. You have these 500 gigabyte storage and RAM servers. Not in today's world. Today's world, it's always fluctuating. You are running whatever the infrastructure that you're running on AWS or Azure or Google. It's going to scale with your demand. The only way for you to keep up with that is to actually automate. So, what are the principles of these automation tools that we're talking about? One, we need to make sure that we're designing for constant change. As I just said, your demand is going to be changing, and therefore your infrastructure is going to be changing. That old world mentality of provisioning for peak, we're going to have the biggest servers, is again long gone. We need to be able to make sure to scale with the amount of demand that we have and make sure that our costs are in line with them. Second, we need to build repeatable components, not snowflakes. Snowflakes in the cloud, snowflakes when building IT is a no-no, because that means everything is going to be completely separate and unique. There's going to be a minimal capacity for efficiency when you're running these workloads. You want to make sure that you can build repeatable, scalable processes. Three, one of Amazon's core principles is that everything fails always, right? So if that is true, we need to anticipate failure. You need to know that the infrastructure is going to fail. Something's going to break. You could have built the most perfect environment, but it's still most likely going to have a hiccup because nothing is perfect. So how do we actually plan for that? And finally, human effort and error equals a security risk. For those of you who saw my LinkedIn posts, it's very easy to make a typo. We do it every day. Imagine you're slacking your friends, you're texting your friends, whatever. You made a typo, one missed number, not a big deal, right? But what about when you're managing your production infrastructure manually and you make that typo? Well, that's actually happened in the past at AWS, and it brought down their systems, right? So we want to make sure that that doesn't happen and automate everything. So when you're designing for constant change, we want to make sure that we're preparing for 4 scenarios. One is a new environment. Hey, I want to test a new feature of my program, or I want to give a customer a sandbox environment. How do I actually scale out for that? 2, updates and infrastructure changes. This would include patching. This would include scale up or scale down. This would include operating system level changes. How do I actually manage the configuration of the infrastructure, right? 3, instance failure. As we just mentioned, everything fails, right? How do we prepare for that? And 4, developers need to deploy code. If you're in an automated world, in a DevOps world, people have CI/CD pipelines now. You know, we're not manually logging into the application and deploying our code to the OS. We're now doing it in an automated fashion. We need to make sure that everything is tested, linted, goes through the gateways, hits dev, stage, prod. We need to make sure that the security is built in every one of these domains. Let's talk about that a little bit more. The first one, a new environment. When you're building a new environment manually, let's just take AWS for example. You log into the console, you have to search for what you're looking for, click through, make all your changes, make all your tags, name it, configure it, bootstrap it. It's going to be pretty slow. Every environment is going to be custom and probably unique. You're not going to make the same changes every time to every infrastructure, right? So I'm going to do it once here, and then twice here, and then 3 times there. What happens when I have 100 different servers? Probably it's going to have a little bit of sprawl. They're not all going to be the same. I might have missed some tags, you know. Then finally, the security and ops teams are going to need to be able to test the new infrastructure. That's going to take some time. We need to make sure that it's scanned for vulnerabilities. We need to make sure that antivirus and IDS, IPS is installed, run any of those scans. It takes some time. In the new environment, when we're automating it, we can use pre-built templates. If we're building everything with infrastructure as code, if we bootstrap it with a configuration management tool, we can actually follow a predetermined process to deploy the code, test all of the resources, bootstrap them with all of the automation tools that we need, any of the security tools we need, and then by the time it's spun up, you're ready to deploy your application within 5 minutes. What does that look like? Well, as I just mentioned, you build it from CloudFormation. That's the first step. You have CloudFormation or Terraform building the infrastructure itself. That's actually going to build the VPCs and the underlying infrastructure, the networking, the subnets, ports, routing, anything like that is going to be built out with that infrastructure as code, right? Then we're going to launch an instance from an Amazon machine image, and that instance is going to be pretty bare bones. At that point, we need to deploy our configuration management tool. It could be Puppet, it could be Chef, it could be Ansible, really of your choice. You could use any of these to bootstrap the process. It's going to install agents, make sure that the instance is sys-hardened, right? Make sure that you are securing any vulnerabilities that might exist, and then push any agent-based changes or configurations that you might need, or any application dependencies, right? This is going to be configuring your DNS, your IDS tooling, log management, log centralization. Make sure that everything is deployed prior to actually accessing the instance, right? CloudFormation and Puppet or Chef or whatever the configuration management tool is can work together in tandem to deploy this whole process before you actually access it. By the time you access it, you have a completely secure instance ready for your application. Next, we need to automate the updates and infrastructure changes. Again, manually, we have a high risk of human error. If I'm going to log into the operating system and make a production change in the middle of the day, I could take the whole environment down, right? How many customers? Let's say I've got 1 million customers using my application, and I had to make a change at the operating system at 2 o'clock. I didn't have it tested. I didn't test it in my staging environment first, or maybe I did, but when I did it in production, it wasn't automated, so I actually made that typo that I was talking about before, right? If I make that change, can't really roll back. If I break something, it's going to take hours to fix that. When you're in an automated environment, you change the code, not the servers. You can change the code once and then deploy it to all of your servers. Back to that example of 100 servers, I need to make one operating system change for a fleet of 100 instances. Manually, I do that 100 times. Probably I'm going to miss something, leave a port open to the world by accident. If I do it in an automated fashion, I can do it once and then deploy it for everything. These changes can be rolled back in version control, have everything stored in Git, and then if something didn't work, I roll it back and then continue business as usual. Every server is going to maintain its ideal configuration because we have that configuration management tool in there that's looking and making sure, oh, all of these 100 instances need to have X, Y, and Z agent deployed. Let's say it has Trend Micro deployed for antivirus and anti-malware. It's going to continuously check in and say, this is working, this is on, this is deployed. If it's not, it's going to make that change automatically. So as you can see here, we're going to push multiple changes with tags. We can roll back. The first push, we're going to install SSM, for example, an AWS systems management agent on the instances, right? Then all the way up, we can enable the SSM role on all the instances. If that didn't actually work, then we can roll back just to the installation patch, redeploy that, and you're all good. Third, failures. Failures always happen. We cannot prevent failures from happening, but we can prevent outages from happening. We can create a self-healing environment. And the only way to really create that self-healing environment is to pre-script and pre-deploy everything. In a manual environment, failure happens, it alerts a human. Human needs to go find out where this went, log into the operating system, figure out what the issue is, go through a long troubleshooting process, high potential downtime. Maybe you're down for 2 hours, let's say. Let's say you're down for 24 hours while somebody's trying to figure this out. Very not scalable. In an automated environment, you can fail over to another instance in your auto-scaling group. That auto-scaling group is going to have that same base AMI that we talked about before that has a known good, right? That known good base AMI, sys-hardened, scanned for vulnerabilities, has your agents deployed. You don't have to worry about, oh, is this going to have those issues? You just move over to the new environment. You can rebuild you can automatically rebuild the failed instances and then put it right back in that auto-scaling group. And then you can actually deploy the most recent code to that instance. As you may recall, I was mentioning that once the instance is up and running and bootstrapped, you can just deploy your application. It's going to have any OS level dependencies, it's going to have those security guardrails in place, so you don't have to worry about configuring that and taking 2 hours to configure your application every time. One thing that people need to keep in mind is that AWS and Azure and these public clouds give you a lot of tools, right? They promote everything is easy in the cloud, everything's going to be available, everything is going to be secure, but you need to remember that it's not automatic, right? You need to actually build these tools and build the automation to make it automatic for yourself. High availability, availability zones, multi-regional disaster recovery, it's all possible, right? You have built-in reliability with services like RDS, you have auto-scaling. However, we need to configure that. You still need to configure always-on availability groups in SQL Server, for example. You still need to configure your own security policies. In AWS, make sure that Security Hub is turned on. Make sure that Guard Duty is turned on. Centralize your logs. At that point, now we know that we have a great baseline. But again, that's going to need to be done with that automation. Next, you need to test it, right? How do we make sure that any of these changes that we're deploying in the environment are actually going to work? Even if they're manual, right? Manually or automated, you need to make sure, I'm making these changes in the environment. How do I know that they work? Well, Netflix, some of you might have heard of this giant company called Netflix. They created something called Chaos Monkey, which is chaos engineering. You're going to artificially inject failures into your environment. You don't know where they are. It's basically like a pen test for reliability, right? It's going to be looking for any way to break your application and see how resilient your environment can withstand, right? So let's say you don't have an auto-scaling group, you have one single instance, you go down, there's a breach, something goes wrong, you're down. You have to take manual steps to get that back up, redeploy a new instance, but if you have that in an auto-scaling group, you can just fail over to that second instance, as we mentioned before. So Chaos Monkey, chaos engineering, is a great way for you to actually understand your failure scenarios and anticipate errors where you might not have known otherwise. And finally, the last design would be developers deploying the code, right? When you're deploying the code manually on your boxes, infrastructure doesn't change, something could break, there's potential conflicts between packages and updates. Let's say you're actually trying to deploy something that's Python 3, but it's only got Python 2 on the box. You didn't have a linter or a syntax check or anything like that. It's going to break the application, right? With a CI/CD pipeline with the built-in configuration management and application deployment, we actually can leverage these AWS native tools. We can leverage an AWS service catalog to have pre-built templates that are joined together. I know that I'm going to have this environment that has one account with 5 VPCs and 3 subnets in each. Each one has their own availability zone, and it's going to have 3 EC2 instances and an RDS instance. We can actually template all of that, put it in a service catalog, and then achieve a push button deploy, right? It's going to allow better configuration management and leveraging containers, as we were talking about before. Any one of those more cutting edge technologies like serverless, containerization, or Kubernetes. What does that pipeline look like? Well, service catalog is going to push a change or a little tick to GitLab and say, hey, let's push this change. Let's build that ECS cluster. GitLab is going to commit that change. It's going to pull the base image from Docker. It's going to build the image with your automation tool, Jenkins, could be Circle CI, Octopus Deploy, anything like that. And then push a new image to the repository, but also push the new image into the container service, whether that's ECS, EKS, and you have a full tip-to-tail automated deploy from your templates all the way through to your AWS environment. So let's talk about some of these core concepts, right? It's expensive and time-consuming to fix something, right? Oftentimes, customers come to us and they say, hey, I have this environment that was built 10 years ago. We haven't really kept up with it. We've just made a bunch of changes. We don't really know what's in there. Some things break. And so we say, okay, well, let's take a look at your requirements and let's see if it's actually possible to fix it. Most likely what's going to happen is it's going to be much faster if we just build you a net new environment that is ready and immutable, right? You have the baseline AMIs that we're talking about, and at the end of the day, you have an automated pipeline that can automatically deploy any of these changes that we're talking about in the blink of an eye, right? So why fix a server when you can throw it away and build a new one? Benefits of the disposable infrastructure concept is you never stray from a known good. If something ever strays from that known good, again, you could just throw it away and build a new one, right? You're forced to test the failure process. There's a higher certainty of appropriate failure response because we're doing things like that Chaos Monkey process where we're looking to inject failures, see where we can be more resilient, and then adjust. If something does break, we fail over to the other environment, or we just deploy a new infrastructure from that AMI. We don't ever have to change that AMI. Finally, being prepared makes failure trivial. It's just business as usual. The only caveat here is you need to make sure that that process is fully automated. You need to make sure that that boot process is automated. As soon as the new instance comes up in that auto-scaling group, it's got all of your security guardrails, it's got all of your application dependencies and your OS dependencies deployed, so you don't have to waste time doing those once the infrastructure is up. So let's talk about an actual use case. This was an enterprise backup software. They host critical data for the majority of the Fortune 500 enterprises, so obviously they have a high potential threat exposure. Everybody's looking at them to hack, right? This is going to be a huge win. They had a new application and they wanted to test the viability of immutable infrastructure. How do we actually bake these AMIs? How do we bake the infrastructure to just have it easily redeployable? Well, we had a custom solution for them. We built the environment from a CloudFormation template library. As I was mentioning before, you can templatize and parameterize these templates to basically configure whatever environment you want. You want 5 VPCs, 3 subnets, 3 availability zones, 100 EC2 instances, whatever the number is. You parameterize that, and then you can redeploy that into different environments, different SDLC tiers. But you create that base level AMI. That base level AMI is going to have, it's going to be sys hardened. It's going to have those security agents. You're going to know that you have IDS IPS installed. Your security protocols and ports and routing are all configured. So you don't have to worry about if something breaks. If something does break, you just rinse and repeat. Fail over to the next instance, and then deploy a new version of that container or that AMI. Basically, what we came up with was a complete DevSecOps as a service solution. What did it result in? Well, they virtually never had an instance failure. It was a 0.001% failure rate. We had basically a 100% uptime for their production application, and we achieved a single-click deployment to production without any instance configuration tasks. We didn't have to worry about bootstrapping the instances because the AMI was already a golden AMI. We had a pipeline that started with that service catalog to create that golden AMI, bootstrap it, have everything there, push the new image, save that AMI as the golden AMI, and then deploy anytime we needed to deploy a new change to the code. You just pull from that AMI, uses that base AMI, makes the change to the code, creates a new AMI, and then you're off to the races. There were no residual impacts from previous failed or past tests. You could roll back if there were any issues. And finally, it resulted in a 60% higher deployment efficiency with similar projects within the company. So we were able to take this as a proof of concept for this new application that they have and redeploy it, reuse the methodology for the rest of their infrastructure. So by the end, this Fortune 500 company that everybody uses basically had a completely automated pipeline from tip to tail, making sure that all of their automation security tools were deployed at default at the inception of their projects. So, what are the security impacts of automation? Well, we can prevent that human error that we've been talking about. No more typos. We have a controlled, standardized build process. We don't have to worry about manually deploying your infrastructure, manually making sure that these agents are installed. The agent's already installed. Now we need to make sure that the agent is collecting, right? We need to make sure that the IDS and IPS solutions are tracking, and we have somebody else reviewing it or software reviewing those logs. You have controlled and standardized update processes. You don't have to worry about patching a million times. We're going to get into patching in a little bit. But ultimately, you have little to no human direct interaction with the environment, really ever. You're going to be looking at the dev and stage environments probably frequently, but in production, everything is going to be automated, and any changes that go into the pipeline are going to be made on the front end so that by the time it hits production, everything is already solved for. So, patching. We talk about patching all the time, right? Everybody loves patching. Ron loves Patch Tuesday. It's the bane of everybody's existence because it stinks to patch 100 different things, and 100 different things could have 100 different problems. But if you have this golden AMI process that we're talking about, you only need to patch that single AMI. Make sure that AMI is properly deployed, properly patched, updated, Everything is in the most up-to-date versions. And then you just deploy that AMI for the rest of the environment. You have consistent versions across all of your environments. You have no vulnerabilities across all your environments. And then let's say something comes up, a new patch comes up, you repeat that process again. You patch that one AMI, and then you redeploy that to the rest of the environment. Fail over to the other instances in the auto-scaling group while things are deploying, and you're, again, off to the races. You want to make sure that you have monitoring tools in place for your security automation. If you look at this simple environment right here, let's say that this instance has a configuration that's open to the world. The route table says it's open 0.0.0.0/0 at SSH, for example, right? That's a big no-no. It's kind of hard to find that in this environment, but in an environment of however many instances, this is 12, 15 instances, you could probably find it pretty quickly. But what about at scale? How do you find that when you have 4 different VPCs across 4 different accounts? It's going to be much harder to find, right? So you need to have automation tools and monitoring to look and check that nothing is open to the world, everything is encrypted, your agents are deployed, etc. Speaking of encryption, we want to make sure that these are baseline policies, right? If you join us on Thursday for the Thursday Angelbeat, I'll be talking about Control Tower and how we can deploy guardrail policies at the very beginning foundation of your environment. But you want to make sure that all of your objects are deployed in an encrypted fashion, right? You don't want to allow anybody to deploy unencrypted data. If you have PII customers, PHI, PCI customers, that is sensitive data. We don't want that to be publicly accessible or unencrypted, right? How do we change that? Well, we make that underlying policy say we just don't allow it. You deny any unencrypted object uploads to S3, to your EBS volumes, and you should be good to go. Logicworks has extensive experience with this because most of our customers fall in the hyper-compliant PCI, HIPAA, high-trust type worlds, and so we have to have an eye for security and compliance. How do we do that? Well, we leverage automation. So what does this pipeline look like? Well, let's talk about them individually. We're talking a lot about the security groups, the ports, firewalls, route tables, subnets, networking. All of those configurations are going to be handled by the infrastructure as code automation tool, whether it's CloudFormation, Terraform, if you're in Azure, ARM templates, right? You want to make sure that the infrastructure itself within the cloud is going to be repeatable and scalable. That's going to be handled with that infrastructure as code. Then, anything that's configuration of the instance or of the service is going to fall into the configuration management tool bucket, whether that's Puppet, Ansible, Chef. You want to make sure that things are encrypted. You have agents for antivirus, anti-malware, log shipping, log aggregation, centralization, IPS, IDS. Those tools are going to be deployed and managed on an ongoing basis by those configuration management tools. So by the end, you have a full pipeline with the infrastructure of the cloud and then the configuration of the infrastructure in automated templates that you can script and redeploy. So that was a lot, but to summarize, automation is really the only way to survive in a modern world in our DevOps environments, right? So you should do it, but that doesn't mean that you need to have a completely automated pipeline at step 1. Any step forward is great. You don't need to have the full automation pipeline as we were talking about today. If you have a CI/CD pipeline at first and you have some checks, that's great. One step in the right direction, right? Next, we can configure the configuration management to deploy your automated security tools or manage your pipelines or your infrastructure deployments. It doesn't all have to happen at the same time. But most importantly, if you don't want to worry about your infrastructure and you want to focus on your application level DevOps, contact Logicworks. Logicworks is a leading provider of cloud migration and managed services. We are internally audited and compliant with HIPAA, PCI, SOC 1 and SOC 2. We're high trust certified. We handle a lot of GDPR customers, and we're an AWS Premier Consulting Partner and Azure Expert MSP and Gold Partner. So if you have any questions, I'm around. Feel free to send us an email at websales@logicworks.net. And yeah, thank you.